Folks, we talked about the mobile phase. We talked about the mobile phase getting sucked up through the instrument. And we said the purpose of that, or what was doing that, was the pump. And if our pump goes bad, we get no mobile phase, which means we get no separation, which means we get no chromatogram. So what happens after the pump? So I'm just going to kind of draw a flow chart up here. So mobile phase box goes into a pump, and that pump is basically creating some high pressure, and that's eventually going to go into what our next piece that we need to talk about is the injector. All right, so what's so special about the injector? What are some things that I need to watch out for? Can I clean the injector? How do I maintain the injector to make sure that the instrument is doing its proper job? Okay, so the first thing that we have to understand is that most of the injectors on an IC instrument, they're not like gas chromatography that we've talked about already. These IC injectors, they are very specific in the volume, and it's what we would call a fixed volume, meaning that I do not have control most of the time. Okay, I'm going to say most of the time. I do not have control of a needle that will suck up a certain amount of sample and inject it into the machine for me. A lot of the ion chromatographs are not made that way. At least ours is not. What happens is that I do have choices, and those choices are specific amounts of sample that gets injected into the instrument. Those choices, though, are really relied upon by a piece that we call the loop. So if I want to inject different amounts of material, I can do that. But I need the proper loop size in order to inject that proper amount. Okay? So this is a piece of the injector that we do need to talk about because it is a place that we can replace and exchange for a new size. And it's pretty easy to pop off and to put back on. But I've got to be able to know where I can find this. And I've got to know where the injector port is located as well, because that's going to require some maintenance too. So most of the injectors, they have two positions. And the first position is something that we would call a load position. And the next one is what we would call the inject position. You know, a lot of the older HPLCs and stuff would have this basically on the outside because this was maybe before autosamplers, or autosamplers were kind of expensive and you got to manually do it. So you have to manually put the sample on, load it up, and then switch the injector port over to inject physically on your own before you could get a sample that would be analyzed or ran. But, you know, these two kind of steps are still recognized. The machine's just doing it for you now. You don't manually have to do it anymore. And we still need to talk about these and how they're working. So we're going to take a look at the load position, and we're going to take a look at the inject position and talk about the difference. As far as the loop goes, this is kind of how I need you to think of it. This loop is a specific amount or a length that will hold a specific amount of material. There's always going to be a little tag on it, and this tag will tell you the volume that that loop is made to handle. So you never want to cut the loop, okay? If you think the loop is crapped up with sludge and material that you can't get out of there, do not go and cut the loops, especially the ends, off of the loop, because it is made to specifically handle a certain amount. And by doing that, you have now changed that amount that you should be injecting. Now, if you do that, I want you to keep something else in mind. If this volume tag says 20 microliters and you cut off the ends, it's not 20 microliters anymore. But something else happens here. even if it's not 20 microliters anymore, it's going to be consistent. So you could run a series of standards, and you could run some samples, and you might get the proper data. The problem is that your areas might be a little bit different from the previous runs. And that's because you've chopped the loop down and you've allowed less amount of sample to go into the machine. And that less amount of sample also means a less area for each component that's present. So what I'm saying to you is that I'm telling you not to cut the ends of the loop off because you are messing with the total volumes. That is very important if you have to kind of compare it to previous runs that you've been doing. You just need to realize that those numbers are going to be different. If that doesn't matter to you, though, you can cut them off, and you can just kind of pick up from that point on and start running standards and start running samples, and everything's going to work out fine, but you're not going to be injecting 20 microliters exactly anymore. It's always going to be less than that because you've cut the ends off of them. Normally, these loop sizes, they go from 20 all the way up to 100 microliters. That's the normal range of what we would see that would be required by a method. What we have, we've got a couple of 20 microliters. We also have a couple of 100 microliter loop sizes. We've got two machines, and for each machine, we probably have a 20 and a 100 loop, just in case we need to inject a little bit more sample. The bigger loop sizes are required, especially if you have really low concentrations of ions. So this could be a cation, or it could be an anion that you're trying to measure. If those are super low, you might require more sample in order to go into the machine, so that way the detector can see those a little bit better. So if you give it more, it can maybe see it, versus give it a small sample with an extremely low concentration of anion or cation. And good luck if your chromatogram just comes right above the baseline and goes right back down. So that really depends on what you're trying to measure. It depends on the concentration. Normally, the lower the concentration, the higher the loop size needs to be. You need to inject more so that way the machine can see them. So 20 to 100 microliters is the normal range for that loop. We need to look at the loop, at least kind of figure out what that thing looks like, and I'll show you a picture of that in just a second. And then on this injector, we're going to have normally what we call a 6-port injector. All right, so I'm going to just draw kind of a run-of-the-mill injector. So here's basically a circle that represents my injector right there. And then my loop is going to be a part of this injector. So this loop is going to kind of come out, and then I'm going to have this kind of loop that goes on, and then it kind of goes back in. Those are 2 ports of this 6-port injector. Ta-da! Right? So I've got 4 more ports that I need to talk about. And we're going to take a look at this in the diagram. So 2 of the ports are reserved for the loop. You got to think of it as an entry into the loop and an exit out of the loop. So there's going to be 4 more that we need to focus on because those are doing a specific job as well. And this load and the inject will rely on the function of that 6-port injector in order to do its job, and maybe a little bit of maintenance work along with it too at the same time. So let me kind of show you a better diagram. If I'm going to draw this, it's going to be pretty ugly and pretty nasty. So I've got kind of an image that I would like to show you as far as the loop is concerned. And let me pull that up. So here's an image of the 6-port loop that we have just talked about. And what you're seeing here is that 2 of these, like I told you before, are really reserved for the loop itself. Okay, so here's the injector, this round piece that's sitting back here in the back. That is the injector port. And then here is one of those ports. Right there we go. So there's one. And that goes into the loop, which are going to kind of curve around a little bit on you. Sometimes they can be that way, depending on the length. And then that loop has to go into another port, and right there it is. No big deal. I told you it's going to take up 2 of them, right? So there's my sample loop. So now you're probably wondering, okay, well, what about the others? Okay, why are the others present? Well, if you notice this one entry into this injector port, that kind of flows down to the next port. Remember, it's a 6-port injector, and that goes out of the system. All right? Well, I've got to have sample that comes in. So here's my sample. And that sample is going to be pulled through, and that goes into one of these other ports. So that's the entry into the entire instrument. And then that flows into the sample loop, and the sample goes through the sample loop, and then it goes into this other port, which feeds it into the next one, and that takes it out of the instrument and into a waste jug. Notice that it doesn't have access right now to the inside of the flow path. This is the area of what we would call the inject, the load. That's my load position. So normally what would happen if I'm using an auto sampler or if I'm using a manual injection syringe, I am pulling sample or pushing sample through the sample loop and I'm loading it up. That is why we do not have access to basically changing the volumes up. That sample loop is specifically made to hold a certain volume. That volume cannot be changed. The loop cannot be changed or modified. And that's because if I do, that no longer is going to be injecting that proper amount anymore. So I can sit here with a syringe and I can pull all the way through as much as I want to pull through. And the only thing that's going to happen is that my sample is going to flow through this chamber, this injector port. It's just going to flow into the injector port. It's going to go through the loop. It's going to come out the other end and out of the machine. And this is probably a waste beaker that I'm dumping it into here. I can keep on doing that. I can keep on flushing as much as I want to flush. It doesn't really matter. I'm just wasting sample if I do. So how much should I actually pull through before I stop? Because the whole purpose of this is to take this loop and fill it completely full. Overfill it. That's why we're kind of pulling all the sample through as we can. They normally tell you about 10 times the amount. So for instance, if this is a 20 microliter loop, then I need to pull at least 10 times that amount through the loop. That way it flushes it, it cleans it, there's no contamination from the sample, and I will have a very clean sample that's representative of that standard or that sample I'm getting ready to inject. There's no carryover. So 20 times 10 is 200, so 200 microliters at least. If you were in the laboratory and you were pulling sample through, I would actually tell you to pull about 2 milliliters of sample through. That is way more than what's needed, but it's a workable amount that you can physically see. It is fully flushed. Most of the time, we always have more than 2 milliliters of a sample anyway, so it's not a big deal. But that's normally the amount that I will tell you to inject. All right, so that's the sample loop in the load position. Now, let's talk about the other injector that's on your screen to the right. What happens here is that this load position is loading the loop. The loop is overfilled, and that loop is going to hold a certain amount. In the next step, what happens is you have to imagine that this loop will kind of rotate in a way. Or tunnels are cut off and other tunnels are opened up. What do I mean by that? Well, let's take a look. This is what we would call the inject position. In the inject position, notice what happens. The sample's coming through, It goes through the first port, but it can't go over to the sample loop anymore. That chamber is now closed off. So the only option that it has is to go left-handed here. And it goes left-handed to that port, and the only route that it's got from here is to the waste jug. So if you're still pulling sample through at the moment of injection, it's no big deal, because the injector port is going to close those routes off and no more sample is going to go through, and these extra parts of the sample will just go out to a waste jug. It's not going to affect anything at all. So if you pay attention to the instrument and you hear that click sound, that click is the injector port doing its job. And you might hear that sound and you might see the instrument on the software go into injection mode. And when you do that, you still might see our auto sampler still pumping. And that's fine. That extra sample is not going to interfere with anything. It's already filled my loop up. So when those chambers close down, all of that extra pull of sample that's coming through, it's just going to go to waste. It's not getting actually injected into the machine. All right, so let's see kind of what happens with our other stuff, right? I mean, right here is where my sample was. I mean, right there was the loop. So I've got a pump. That pump is pumping mobile phase through, right? So here's the pump. And in the load position, that pump is getting into the injector. It goes through that port. And the only route that it can go is through this other port and then out into the column. That mobile phase is not getting mixed in with my sample at this moment, right? I mean, that's the purpose of the injector port. I'm loading my sample up. When this valve switches over to the inject, though, something happens. I've got my sample that's basically loaded up. Down here, it's ready to go. When the injector turns over to the inject position, my pump that carries my mobile phase is going to go through like it always has, and it says, whoa, wait a minute, I can't go right-handed anymore. I had been going right-handed, and I had been going through the column, but this injector is going to reroute me. And now it reroutes me over to this port. And now from that point, I can't go anymore. So I got to follow this flow path. And what happens with this flow path is that my eluent now is going to be mixing with my sample that's on the screen. And that eluent and that sample goes back up into its previous location. The only way that it can go now is through this entry port and then out into the column. All right? So that's how the injector will do its job. One position is keeping the sample separated from the mobile phase path. My sample gets pulled into the loop, it overfills the loop, and the extra goes into a waste beaker. By switching the valve over to the inject, think of it just as turning. That's all that it's done. Okay? By switching it over to the inject, I have now cut off paths for this mobile phase and sample to flow. And by cutting off those paths, I now force the mobile phase to now go through the loop and out the other end and eventually into the column. All right? So don't be surprised if you see this image on a test. What I like to do here is I like to give you an image of a port, and I kind of like for you to explain what the 6-port injector port can do. So talk about the different ports and why they're there. Talk about maybe how things flow. What's the purpose of the 6 points of entry or exit here, and how does it do its job the proper way? So make sure that you feel comfortable with that kind of image or that kind of diagram, and I think you'll be okay with that question when the test comes around or when the assignment comes around. So in the next video, what we'll do is we'll take a look at some videos. I'll kind of show you a real picture of an injector port and a loop, and I'll talk a little bit more about it.